Hello student, in last lecture we have started the chapter solution of algebraic and transcendental equations. There are different methods already I have told, but before that revise the definition of algebraic equation. Algebraic equation means if f of x is a polynomial of degree n, then f of x is equals to 0 is called as a algebraic equation if f of x is a polynomial function. And the equation f of x is equals to 0 is called as a transcendental equation if the f of x contains some other functions such as trigonometric function, logarithmic function, exponential function. We have seen the first method of solving such equation, that is a bisection method. The bisection method is depend upon the theorem if we consider the interval a to b, and if we find f of a and f of b, if this f of a and f of b has an opposite sign, then the solution lies between a and b. Using this, suppose this is a point A, this is a point B. That means we shall assume the values A and B such that f of A and f of B has opposite sign. Suppose find f of A, also find f of B. If f of A is positive and f of B is negative, that means f of A and f of B has a opposite sign, then solution of f of x is equals to 0 lies between A and B, and we shall obtain our first approximate value as x1 is equals to A plus B, or we may consider x0. x0 is equals to A plus B divided by 2. It exactly lies at the center, and suppose this is the x0. Then find f of x0. If f of x0 is equal to 0, then x0 is the root of the equation f of x is equals to 0. If f of x is not equal to 0, then as we will find f of x0 here. F of x0 is either positive or negative. If f of x0 is a positive, then f of x0 and f of b has a opposite sign, and therefore the solution lies between x0 and b. If f of 0 is a negative, then f of x0 and f of a has opposite sign, and therefore solution lies between a and x0. Whatever we shall consider f of x0 is a negative, then these two has a opposite sign, therefore solution lies between a and x0. And we shall bisect this interval again, taking x1 is equals to a plus x0 upon 2 at the center. This will be a x1. If f of x1 is equals to 0, the equation f of x is equal to 0 has a solution as a x1. If it is not equal to 0, again we have obtained f of x1, it is either positive or negative. If it is positive, f of x1 and f of x0 has opposite sign, and therefore solution lies between this interval. And I can bisect this interval, that is x1 plus x0 divided by 2. We shall consider this as a x2. And continuing in this way, we shall come to the closer to our approximate solution. Then we shall bisect this interval. Again bisecting either this or solution or roots of the equation f of x is equal to 0. This method is called as a bisection method. We have seen in last lecture. Also we have solved some problems. Now today we shall see the method of false position. This method is also dependent upon the same theorem. If f of a and f of b has an opposite sign, then root lies between a and b. Okay? Now we choose, suppose we have to solve the problem f of x is equals to 0. We have to obtain root of this equation. It is either polynomial equation. If f of x is a polynomial equation, it will become an algebraic equation. And if f of x has some other functions, then f of x is equal to 0 is a transcendental equation. Okay? Now we have to find the roots of the equation f of x is equal to 0 by the method of false position. Similar to the bisection method, we choose two values. In previous case, we have limited it by a and b such that f of a and f of b has a opposite sign. In this case, we choose two values or 2 points x0 and x1 such that f of x0 and f of x1 have opposite signs. Either f of x is equal to 0. If f of x0 is positive, then it must be negative. Or if it is negative, then f of x1 must be positive. They must have an opposite sign. If f of x0 and f of x1 has an opposite sign, the root lies between x0 and x1 according to bisection method. But in this case, we shall obtain the equation of a chord joining the point x0 and f of x0. Means if we shall consider x0 is 1 point, this is the x0, then f of x0 means this is the y coordinate. That means x0 and f of x0 is a point which lie on the given curve. This is the curve f of x is equals to 0. This is the curve f of x is equals to 0. We have to find the root of this equation by using method of false position. Okay? As we have taken initially 2 points x0 and y0 satisfying the condition that f of x0 and f of x1 has opposite sign, and therefore x0 f of x0 and x1 f of x1 are 2 points which lie on the given curve f of x is equals to 0. We have denoted the point A as x0 f of x0, B as x1 f of x1. Then join the chord AB, that we join the points AB, and the line AB is called as a chord of this curve f of x is equals to 0. Okay? Now we shall assume that already we have seen x0 and x1. This chord intersects the x-axis in the point x2. Okay? And we have to find the value of x2 here. To find the value of x2, find the equation of this chord AB. That means use the 2-point form of the equation of the line in plane. That means if we have 2 points x1, y1 and x2, y2, the equation of a line joining these 2 points is given by y minus y1 divided by x minus x1 is equals to y2 minus y1 divided by x2 minus x1. And using this form, our points are x0 f of x0, x1 f of x1. The equation of the chord AB comes to be y minus f of x0, y1 means first point. Okay, f of x0. First y coordinate, that is f of x0 divided by x minus x0 is equals to y2 minus y1. y2 means second y coordinate, that is f of x1 minus y1. y1 means first coordinate, f of x0 divided by x1 minus x0, because our points are x2 means second, that is x1, and minus x1 means first point, that is our first point is x0. That means equation of chord AB will become y minus f of x0 divided by x minus x0 is equals to f of x1 minus f of x0 divided by x1 minus x0. This is the equation of chord AB. Now to find the value, the point x2, that means x2 is distance of that point from the origin. To find that value, we put y is equal to 0 in this equation. If we put y is equal to 0, this term become 0. Then take cross multiplication. Cross multiplication is f of x1 minus f of x0 into x minus x0, and this will be f of x0 into x1 minus x0. This f of x0 into x1 minus x0 is taken here. F of x0 into x1 minus x0 is equals to x minus x0 into f of x1 minus f of x0. Then transfer this on other side, goes to the denominator, and it will become f of x1 minus f of x0. And this, taking this minus x0 on right side, we get x is equals to x0 minus f of x0 divided by f of x1 minus f of x0 into x1 minus x0. This is simple calculation. I am not written there. You can, by taking cross multiplication and simplifying, you will get value of x like this. This is the value of x after taking y is equals to 0. Now this is the new value of x, and the new value of x0, x1. The new value of x is denoted by as a x2. We shall consider this as a x2. Means at first we have x is equal to this, and then we shall consider second approximation is given by x2 is equal to this right hand side. Okay, and this is a x2. The x2 is equal to x0 minus f of x0 divided by f of x1 minus f of x0 into x1 minus x0. Okay, means in this equation putting y equal to 0, we get new value of x. That new value of x is denoted by x2, and we shall consider this is the second approximation to the solution of f of x is equal to 0. Now then find f of x2. And if f of x2 and f of x0 are opposite sign, then the root lies between x0 and x2. Okay? By using that theorem, root lies between x0 and x2. And then in this equation, we replace this x0 by x2. Replace x0 by x2. And what we did after replacing x0 by x2? That is the next new approximation. Replacing x0 by x2, we get x3 is equals to x2 minus f of x2 divided by f of x1 minus f of x2 into x1 minus x2, and this is the new approximation. x3 is equal to x2 minus f of x2 divided by f of x1 minus f of x2 into x1 minus x2, and continuing similar manner we can find the corresponding next approximation. What will be next approximation? To obtain x4 we have to replace x1 by x3. For next operation replace x1 by x3, that means x4 is equals to x2 minus f of x2 divided by f of x3 minus f of x2 and so on. This is the next operation. We shall continue in this manner and obtain a solution or approximate solution of the equation f of x is equals to 0. Only you have to remember that this formula. Okay. First approximation is 0 and x1, then x2 is equal to this one, then replace x0 by x2 and continue like this. You will get the corresponding approximation. Problem can be solved by substituting the values only. If you want, you can see my books. The problem is given, solved problems are given, 2 or 3 problems are solved there. But as our exam is objective type, I am not taking here. Now we shall stop with this method. In next lecture, we shall see the Newton-Raphson method to solve the algebraic and transcendental equation. Thank you.